A sum of €5,000 is invested in an 8-year government bond with an annual equivalent rate, that is AER, of 6%. Find the value of the investment when it matures in 8 years' time. So the easiest thing to do is use the compound interest formula, which is covered in other videos. So the principal is the amount that's invested, which is 5,000. 1 plus the rate of interest is 6, so it's 1 plus 6 over 100 to the power of the time, which is 8 years. So we have 5,000 multiplied by 1 plus 6 over 100. Well, that's 1.06. And that has to be raised to the power of 8. Actually, you don't need brackets around 1.06. So that's what the investment will amount to after 8 years, €7969.24. By the way, just to remind you of how this formula works, if the money is invested for 1 year, it will grow to 6% more than what it was worth initially. So we need to increase 5,000 by 6%. To increase a number by 6%, you multiply it by 1.06. So that's after 1 year. And this amount goes in for a second year, and we have to increase this amount by 1.06. Or, sorry, we have to increase this amount by 6%, so we multiply it by 1.06. And this will be the new amount after 2 years. So for the third year, we need to increase all of this by 6%, so we just multiply it all by 1.06, and so on for 8 years. So that's why we put 1.06 to the power of 8. A different investment bond gives 20% interest after 8 years. Calculate the AER for this bond. So that means that the principal, that is the money we invest, grows to 120% what it was worth initially. But 120% is 1.2. Or in other words, we increase P by 20%. To increase P by 20%, we multiply by 1.2, because 1.2 is 120%. It's just 120 divided by 100. Our principal is invested for 8 years. What we need to find is the AER. So we can just use this formula here. We just rearrange it to find R. R is what's missing. So we start by dividing both sides of our formula by P. So that gives us 1 plus R over 100 to the power of T, where I've put in 8 for T. So this will be equal to A divided by P. Well, A is what our principal amounts to. So A is 1.2p. So it's 1.2p divided by p. These p's cancel out. So that means we get 1.2 here. Now, how do we find r? We have 1 plus r over 100 raised to the power of 8. How do we get at r? Now, there are two ways we can do this. The first way is to put both sides to the power of 1 over 8. So put the left-hand side to the power of 1 over 8, and then put the right-hand side to the power of 1 over 8. Now, why do we do that? Well, we use our rule for powers then. If we have something raised to a power and the whole lot is raised to another power, we just multiply these powers together. It's just this rule here, a to the power of m raised to some other power n is a to the power of m times n, where a, m, and n are any numbers. This was covered in the video on powers. So we can just multiply these powers together. 8 times 1 over 8 is 1. So we get 1 plus r over 100 to the power of 1. But of course, anything raised to the power of 1, we can just drop that power. So that's why we choose 1/8, so that when we multiply these, we get 1. But then we must put 1.2 to the power of 1/8. We do the same to both sides. So we have 1.2 to the power of 1/8. So we get this number here. I will write this down to 5 decimal places. So to get r over 100, we just subtract 1 from this number. And to get R, we multiply both sides by 100, so we get 2.305. So just to highlight what we did, we put both sides of this equation to the power of 1/8. Now the other way to do this is to start with this equation and get the log of both sides. So just write log in front of both sides. And then we use one of the rules, a rule for logs. If you haven't seen it before, you can multiply the power in front. So we have 8 log 1 plus R over 100 equals log of 1.2. So now we need to get the log of 1.2. So you just do that in your calculator. Press the log button. We need to divide by 8. We get this number here, which I have written down to 6 decimal places. So the 7th place is 6. We add 1 onto the 6th place. So we get 8 there. Then to get at R, we have to put 10 to the power of both sides, because 10 to the power of log to the base 10 of something just gives us that something. So if you haven't seen logs before, don't worry. We do 10 to the power of 0.009898, and we subtract this 1, multiply by 100, and we get our answer as before, 2.305. Okay, I probably wouldn't recommend doing it this way. It's much easier to do it the other way. If you want to do a check, you could plug 2.305 in for R here, say. So we would have 1 plus 2.305 divided by 100. That's 1.02305. Okay, that's the 1 plus R over 100. So we just divide this by 100. We get, move the decimal point 2 places to the left, we get 0.02305. Add on the 1. Then raise this to the power of 8. Raise this to 8. And you see we get 1.19999, which is practically 1.2, allowing for rounding error.